All right, so let's talk about inverse functions. Let's first, really? The main thing about inverse functions that we're going to do today is two things. We are going to use composition to determine if two functions are inverses of each other. And then we're going to use algebra to figure out the equation for the inverse of a function. So two main skills you're going to practice today. All right? Now this is all predicated that you understand what composition is. So this question is asking, are these two functions inverses of each other? And here's the way you do this. We're going to first use this composition function, and then secondly, use this one. All right, so write down this one here. How would you read this, Caesar? How would you read this one? Perfect. F of g of x. All right? So, I taught you guys to do this last week. I'm going to write down f of x, which is 1 over x plus 2, but where it says x, I'm going to put what? The box.
Yeah.
Okay? So you'll notice my box is quite big because we need to put 1 over x minus 2 into the box. All right? So I'm going to put, in parentheses, 1 over x minus 2. Well, we'll get there, right? I mean, who's teaching the class? Now, you'll notice we don't have anything in front of it. We don't have a constant in front, so we don't need to distribute. So we actually don't need the parentheses. And what Diana's brain has already seen is that when you take away the parentheses, minus 2 plus 2 becomes 0. It's gone. So it's just going to become 1 over, wait for it, 1 over x. Now, I taught some of you 2 years ago, and I taught you that whenever you have 1 over something, that it just becomes something. So like 1 over blue is just blue. Okay? Do I need to prove it? I can prove it. Prove it. Deal. Not everyone does, Bashir. All right, so 1 over x. Do you agree that's the same thing?
Yeah.
Is that the same thing as 1 over x?
Yeah.
You don't agree?
Oh wait, yeah.
1 divided by 1 over x?
Yeah.
Yeah? All right. So if I have 1 over 1 times, what do you do to this fraction? You flip it. So what's 1 over 1 times x over 1? Proved. Now, what did we get when we did f of g of x? We got x. That's what you want to get. Now, let me ask you this question. Yeah, I'm sorry. What if it had said, what if I did f of g of 2? What would I want to get? 2. What if I did f of g of Mr. Brandrick?
Then you want to give Mr. Brandrick.
Exactly. That's what I'm trying to get you guys to see. Most teachers will teach you to do f of g of x, but if you want to get crazy and you did f of g of 2, then you should be getting 2. You want to see what we get? So what's g of 2? That's 1 over 2 minus 2. What's 1/2 minus 2? No. What's 1/2 minus 2? What is it? Close, no. 1/2 minus 2. Negative 1.5. So now let's plug it in here. What's negative 1.5 plus 2?
3.5.
No.
0.5.
0.5. What's 1 over 0.5?
1/2.
Or like 0.5 is 1/2, right?
Yeah.
So it'd be 1 over 1 over 2, which I taught you is just
2, right?
There are some things I know I'm right in. This is one of them. All right. What? I mean, I should be, right? I teach the math. Should know what I'm doing. Let's do the other one. Now, what if I had gotten 6x plus 2 or x plus 4? What if I had not gotten x? Would I need to do this one? No. All right, so if you do the first one and you don't get this value, these are not exactly the same, then you can stop and write they're not inverses of each other. But since I got x,
So we're not finding a number, we're finding a variable?
depends. If I had done f of g of 7, then I want to find 7.
So then it's whatever to the first. So this whole inverse thing is just to see if they're.
It's just to see if they're inverses of each other. Each of these functions has an inverse. I want to know if they're actually inverses of each other. Right?
So x is the inverse of x, or it's x is the inverse of negative.
Well, are you asking what's the inverse of the function x? Is that what you're asking? It is also x, yes. Okay, so let's do the other one. Now I'm going to write down 1 over box minus 2. And in the box, I'm going to put 1 over x plus 2. And we just proved that 1 over something is something. So I'm just going to write down x plus 2. But don't forget what was out here that needs to come down.
So it's x.
Yay!
So then is g f x x. Well, would it not be the inverse because one has to be negative, one has to be.
No, they have to be the same.
So they are inverse.
They are inverses of each other. So f of x, yes, Lily.
Okay, so so the one that's in the numerator
Uh-huh.
for the algebra out. Big fraction and the little fraction,
Okay.
they can just cancel each other out, right? In any kind of situation. Like the one to one.
Like 1 over something?
Like, yeah, like the one to one can always cancel each other
It will always be true, right? Yes, this is always true. Wait, thought I hit it. There we go. 1 over whatever this is, that's what it is. Always.
Like, what if, oh, okay, never mind, I see.
Okay?
Yeah, hold on. Okay, let me just go through.
Yeah.
Okay, so if I were to do this problem, can I just cross this out, like these two out? And
Ooh, good question. Lily had a good question. She said, could I just cross out this stuff? The only reason we can cross out here is because there's nothing else.
Yeah.
So no, you couldn't. That's why you have to deal with this first, and then you can take care of it. So be careful. She asked if you could deal with this first, like 1 over x, but it's not just 1 over x, it's 1 over x minus 2 plus 2.
The whole thing.
It's the whole thing. So you got to deal with simplifying this first, then you can do 1 over something. That's called algebra, right? You learned that freshman, sophomore, junior,
My question
supposedly.
is, f of x is inverse of itself, right? Or
No, f of x and g of x are inverses of each other. I'm going to come back and show this later on in the class. I think it'll help your brain see what we're talking about.
So, like, you know, like f of g of x is, like, all of them are of x.
Mhm.
Isn't it like prescribing that it is going to be inverses because they're both x, so it's going to be x?
Not necessarily, right? Let me just give you an example. All right, you guys should know this function. Do you know that function? It's the cubic function, right? It looks like this. Okay? Do you know the inverse of the cubic function? No? It's the cube root function. That's the invert function. It looks like this. Now, you want to know what's crazy about these two functions?
You would think it was the opposite way?
No, I don't. Maybe, I don't know. What I was going to say is that these two functions are reflections along this line. All inverses reflect on that line. All right, they're all symmetrical on that y equals x line, which is why when we do f of g of x and g of f of x, we're looking for x. Okay?
Symmetrical y?
Yeah, so like, let me show you. So like if this is y equals x, oops. Yeah. Try to put it on there for you. So like here's x cubed, and here's the cube root of x. They should be symmetrical, like mirror images of each other.
On both sides?
Like the whole time. Excuse that, that's a little just, the pen vomited a little bit. Okay? Okay, here's what you're going to do. You're going to try, yikes, I think there's two of them. Yes. You're going to try doing this process for these two functions, x cubed minus 4 and the cube root of x minus 4, and negative 3x plus 5 and x minus 5 over negative 3. This is where we're going to do f of g of x and g of f of x. If you don't get x, when you do the first one, what can you do? Stop and write they're not inverses of each other. But if you get x, you got to do the other one. All right, I'm going to give you 10 minutes. So 10 o'clock. Ready? Go. Absolutely. You could do g of f of x if you want.